Hello, my name is Tony Botting and I'm a simulation specialist at GoEngineer. In this video we'll discuss an example setup to simulate transient natural convection. A coffee cup at room temperature has just been filled with hot liquid at 180 degrees F. As the animation shows, we want to observe convection as the hot fluid comes in contact with the cool inside walls of the cup, becomes less dense and sinks to the bottom. This shows what happens about 8 minutes after filling the cup with hot liquid. The trajectories are colored by local speed and the section cut is colored by temperature of the solid and the liquid. We assume the liquid is initially still so we can observe pure convection due to temperature differences and buoyancy effects. So here's how we set it up. We have the coffee cup here and we'll look at a section view. We need to include a cover for this case because the software will not model the interface between the air and the liquid. Okay, we'll use the wizard and create a new project and a new configuration. And I'll use the SI units. We have a closed cavity internal flow problem and we don't want to exclude that, so I'll uncheck that option. We want heat transfer in the solids. We want time dependent and we'll run for 30 minutes and record results every 30 seconds. And we want gravity so we get the buoyancy effects. We're not using a gas, but we do have a liquid, so we'll choose water. And we want a ceramic for the cup, so I'll choose a typical alumina. We can leave the defaults here for wall conditions since we'll be adding our own wall conditions. For our initial conditions, we want to start out everything at about 75 F, which is about 297 K. And we'll take the default resolution as a start. Now we'll take a look at the input tree. You can see the symmetry, so let's view a section of the model and set the computational domain for half the cup. I'll turn off the section view so we can apply boundary conditions. For this case, we'll use the outer wall option and set the convection to air at 25 watts per square meter K and 297 K, which is 75 degrees. And we'll pick a representative set of outside walls. We won't do the bottom for this case, and we choose to include the cover as a convecting wall too. Now we'll set the initial conditions for the fluid, and we'll need the section view here. This is a very handy feature of flow simulation. We'll select the faces where the hot beverage is contacting the walls, and set the initial temperature to 355 K, which is about 180 degrees F. This works if you have enclosed space for the fluid. Now we'll go ahead and run this analysis. Notice there are no goals specified at this time, but we can add some later. Let's look at the results. I'll hide the lid and make the cup transparent, and we'll generate a cut plot of the temperature. I'll change the scale to read in Fahrenheit units. And we'll animate the temperature over time using the wizard. We'll edit the cut plot and put some vectors in the cut plane. You can control the vector spacing and length with the adjustments. Okay, now we'll hide the cut plot and insert a trajectory plot showing the traces off the inside wall colored by velocity. We'll change to arrows and play an animation of the trajectories. You of course notice the trajectory is only in half the model due to the computational domain restriction on half of the model. In this video, we showed basics for setting up a transient natural convection simulation.